Okay, so question number 10, we asked find which of the operations given in question number 9 has identity. So identity means that basically we said that the given basically a binary operation star on a set A, an element E belonging to A, if it exists, is called identity for operation star if A star E is equal to E star A is equal to A, and for all, of course, for all A belonging to the set A. So now using this definition, let's go and take a look at example number 9. So in example number 9, star is a binary operation defined on the set Q, meaning that the star is a binary operation defined on the set Q, as, for example, the first part of the question is for example A star B is equal to A minus B. So now what this means is that basically what this means is that we said that basically we said that so based on the definition, we said that basically we have to, if E exists in A, then E is an element belonging to A in such a way that basically A star E is equal to A star is equal to E star A is equal to E, which means that for example, you are looking for some number. For example, you're looking for some number for some element E in such a way that A star E is the same thing as E star A is equal to A, right? If I'm not mistaken, because I'm known to make mistakes in this particular definition from time to time, is equal to A, right? So what that means is that, so for example, let's say that you have an ordered pair, for example, in Q, in the Cartesian product of Q and Q, which is, let's say it's A comma E, for example. Then using this, A star E has to be equal to A minus E, and it has to be equal to A. Also, if you have E star A, E comma A, another ordered pair relative to A star E, to another ordered pair relative to A comma E, then E star A has to be equal to E minus A, and again that has to be equal to A. So as you can see, first of all, this has to be commutative, and of course this is not commutative because in the set of, as you can see, basically A minus E has to be equal to A and E minus A has to be equal to A, which is of course not possible, because A minus E is actually the algebraic opposite of E minus A, meaning that, for example, if you write 2 minus 3, that is always equal to negative of 3 minus 2, right? So it's always like that. You cannot, you can say that 2 minus 3 is always not equal to 3 minus 2, at least whenever you're talking about the set of rational numbers. So that means that this element simply does not exist. That means that this element this element does not exist. But now in order to now the answer that I have in the solutions, it simply says that an element E belonging to Q, so it basically summarizes the whole thing for every part of this exercise, and there is 6 parts to this to question number 9. It says that an element E belonging to Q will be the identity element for the operation star, will be the identity element for the operation star if basically A star E is equal to A is equal to E star A for all A belonging to Q. However, there is no such element E. However, there is no such element. There is no such element E belonging to Q with respect to each of the 6 operations with respect to each of the 6 operations satisfying the above condition. Satisfying the above condition. Thus, none of the 6 operations has identity. None of the 6 operations has identity. Now, what this means is that they have examined each and every part of this exercise number 9, and now they have basically reported this much about all of them. But then basically it would be interesting to, and it would be actually interesting to go through each and every one of them. And for example, one thing that you can see here, I mean, there is a whole, of course, ton of things that you can learn in all of these exercises. So in this particular exercise, what I noticed is that, for example, if basically star is not commutative, then of course this is not possible in the first place, meaning that you can simply use the commutativity of star as a condition to find out whether this operation has an identity or not, and that you can see based on this expression or equation over here. We are saying that A star E has to be equal to E star A. That means that basically star is commutative, right? And that of course has to be equal to A. That's of course another story. But if you think about this part, what this means is that star has to be commutative, and well, of course here star is not commutative, and then the identity does not exist. Now let's take the second part of this question. For example, let's go for example question number, the second part is basically A star B is equal to A squared plus B squared. And a squared plus b squared, of course, is commutative, right? So you have basically because it doesn't matter in which order you add a squared to b squared, whether you write a squared plus b squared or b squared plus a squared, both have the same meaning. And so what that means is that this is of course then you can say that star here in this case is commutative. And we talked about this in the previous video. Star is commutative. Now let's see if we can find the identity element here. So the identity element is some element E belonging to Q, because this star is defined on Q, that in such a way that basically E star A is equal to A star E is equal to A. Now I think here, of course, it's not 1, because if you add 1 to anything, you will not get the same thing. But then again, the element does not exist, because any value well, it could be 0, right? No, it couldn't even be 0, because if you take E as 0, let's suppose that we take E as 0, then A star E would be equal to A squared plus 0 squared. A squared plus 0 squared, which is equal to A squared. And this is not equal to A, right? And therefore, and any other value that you take for E, for example, even if you take a 1 squared is going to be equal to 1, then this becomes A squared plus 1, which is not equal to A, or any other value that you pick, it's going to be added to A squared. So then in this case also, you can say that the identity element does not exist. Now, of course, all of these concepts that might seem to be useless, or just some theory related to functions, they have all kinds of applications, of course, in mathematics, meaning that you can always use all of these concepts in many different types of situations in order to do different types of things in mathematics. But in the beginning, of course, everything has to be at least in mathematics, everything seems to be useless or pointless. For example, in the beginning, you learn not the multiplication table, but for example, you start learning about functions. Now, all of these functions, basically, there is a domain, there is a codomain, there is a range, this is mapped to that one, this is bijective, this is subjective, this is not subjective but surjective, and so on and so forth. So the whole thing in the beginning seems to be pointless, but these are actually very, very useful ideas and concepts that you can use in mathematics itself, and then generalize them to, well, every other problem that you're solving in some other in any other branches of science. For example, when you go to physics, of course, without the knowledge of mathematics, of course, there is no way to get anywhere. It's just not possible. Okay, so now part 3 of this question is, for example, we have the same star defined on the set of rational numbers, and we have A star B is equal to A plus AB. And so well, first of all, this is not commutative. This is not commutative because you can see that A star B is equal to A plus AB, and B star A is equal to, well, B plus AB, right? And so you can see that A star B is not equal to B star A, at least for some values of A and B belonging to the set of rational numbers. And so since it's not commutative, then of course there is no question of the identity element existing, because the condition that we use for the identity element, we say that E belonging basically to Q, for example here, A star E has to be equal to E star A, and then it has to be equal to A. So this means that it has to be commutative. And since star is not commutative, then there is no question of basically the identity element existing. Part 3 of this, that was basically part 3. Now part 4 of this question, we have A star B. We have A star B is equal to A minus B whole squared. Now this is commutative. Now here star is commutative because A star B is going to give you the difference of A and B and then whole squared, and B star A is going to give you the difference of A and B whole squared, which is going to be the same number. And we talked about this in the previous video, how that is, and so this is commutative. Now the only thing that we need to check here is whether basically the identity element exists, meaning that, for example, you have to find some number that you subtract from A, and it has to be equal to, so the condition is A star E has to be equal to E star A. It has to be equal to A. Now suppose that I take my E as 0, for example, then A star E would be equal to A star 0. That would be equal to basically A minus 0 whole squared, and then you will get basically A squared, which is not equal to A. So 0 is not the identity element. And any other value that you pick here, it goes into this equation, and then you will get some expression which is not equal to A. So you can say that basically E does not exist. E does not exist. Now part 5 of this question is A star B. A star B is equal to A times B divided by 4. Now here basically star is commutative. Star is commutative because A star B is equal to AB divided by 4. B star is equal to A times B divided by 4. There's no problem there. But suppose that I calculate A star E, for example, and if I take my E as for example 0, then I will not get A because the whole thing goes to 0. If I take my E as 1 even, so then that would be A divided by 4. So it's not going to be equal to A. Taking as 2, then another expression, taking as 3, -1, -2, or any other rational number, which means that basically A star E, meaning that you can say that there is no element E belonging to Q. There is no element E belonging to Q that satisfies the condition A star E is equal to E star A is equal to A. Therefore the identity element does not exist. Right? Now part 6 of this question, we have A star B. We have A star B is equal to AB squared, right? We have AB squared. So if A star B is equal to AB squared, then of course this is not commutative. Star here is not commutative. And therefore E does not exist. E does not exist. Okay. Now the next question is question number 11. Okay, so question number 11, we have let AB. Question number 11, we have let A be equal to the Cartesian product of n and n, and star be the binary operation, on A defined by A comma B star B C comma D is equal to the order pair A plus C comma B plus D. And you want to show that star is commutative and associative. You want to show that star is commutative and associative. Find the identity element for star on A. Find the identity element for star on A, if any. Okay, so to show that basically star is commutative, you can simply calculate A star. You can calculate basically A comma B star C comma D, and that gives you basically A plus C. By definition, it gives you A plus C comma B plus D. Now if I change the order of these two, meaning that if I write C comma D star A comma B, That gives me a plus c. Well, c plus a is the same thing as a plus c in the set of natural numbers. A plus c comma d plus b, which is the same thing as b plus d. Which means that basically a comma b star c comma d is the same thing as c comma d star a comma b, right? And therefore the operation star is commutative. Therefore the operation star is commutative. Of course, there is something that I should have written over here, and that is for example, let a comma b and c comma d belong to, for example, belong to a, because that's the Cartesian product of n and n. Then basically a, b, c, and d belong to n, of course. And then you can based on this, you can conclude that basically the operation star is commutative. Now, to show that basically star is associative, you can say that, for example, let a comma b, c comma d, and e comma f belong to a. And based on that, then you can say that a, b, c, d, e, and f belong to n, of course. Belong to n. So now we have basically a comma b star c comma d star basically e comma f. E comma f is the same thing as basically a plus c comma b plus d star e comma f. And that is the same thing as a plus c plus e comma b plus d plus f. Now if I write this as basically a comma b star c comma d star e comma f, that is going to be equal to a comma b star basically c plus e comma d plus f, which is the same thing as a plus c plus e comma b plus d plus f. And as you can see, you can say that basically a comma b star c comma d star e comma f is the same thing as a comma b star c comma d star e comma f for all a b c d e f belonging to the set of natural numbers. Therefore Therefore, star is associative. Now, in order to show that, in order to find the identity element, now the identity element E belonging to N exists if it exists, of course. If it exists, must fulfill the condition. Must fulfill. How do you write fulfill? I know that it does have two, basically two L's somewhere, but exactly where I do not remember right now. Fulfill. Yes. So must fulfill the condition. The condition basically A star E is equal to E star A. E star A is equal to A. Which means that if I take any element, for example, now let us suppose that for example A comma B belongs to A, for example. Now we need to show that there exists another ordered pair, for example. We need to show that there exists another ordered pair, say for example, I don't know, C comma D belonging to the set A, such that A comma B star C comma D is equal to C comma D star A comma B is equal to A comma B, right? So now let's set C comma D. Let us set C comma D equal to 0 comma 0. Then we have basically A comma B star basically C comma D, which is equal to 0 comma 0, is equal to A plus 0 comma B plus 0, which is equal to A comma B. Now if I write 0 comma 0 star A comma B, that's equal to 0 plus A comma 0 plus B, which is equal to A comma B. Therefore, 0 comma 0 is the identity element, in A. And in order to make sure that I didn't make any mistakes here, I think I have made a mistake. Oh, I made a mistake actually. I made a mistake here. So the mistake is that basically 0 does not belong to the set of natural numbers. I was under the impression that I was working in the set of rational numbers. Now, of course, 0, 0 does not belong to the set of to A. It cannot belong to A, and therefore you can say that. Of course, you can say that. You can say that all of what I have written over here is actually not right. It's not correct. So basically here we can say that we know that no such element exists in A. Therefore star does not have an identity. Element, right? So I apologize for the mistake, but I was actually under the impression that I was working in the set of rational numbers based on what I was doing in the previous example. So I wasn't aware of the fact that we were working in the set of natural numbers. In the set of natural numbers, 0, of course, you don't have it. Now, question number 12. Question number 12, we have basically state whether the following statements are true or false and justify your answers. So number 1, we have for an arbitrary binary operation star on a set n, for an arbitrary binary operation on star on a set n, A star A is equal to A for all A belonging to the set of natural numbers. So let's see if that is the case. So what we are saying is that, let's see if that is true. So we are saying for an arbitrary binary operation on a set n, then on a set n, then A star A is equal to A for all A belonging to n. So when we are saying an arbitrary binary operation, that means that I can take any example in order to create a counter example for this statement, and but of course it has to be in the set of natural numbers, right? So suppose that for example the operation is, for example, let's say that the operation is, let's say that A star B is equal to A minus B. Then of course in this case, if I define A star B as A minus B, then A star A would be equal to A minus A, which is equal to 0, which is not equal to A, which proves this statement, to be false. Now let's see what sort of solution they have here. So what they have the solution, they have written it as basically define an operation star define an operation star on n as, for example, a star b is equal to a plus b for every a and b belonging to n. Right, so this is anything that you can define, because here the question or the statement is saying for an arbitrary binary operation. So that means that you can define anything you want. Then in particular for b is equal to a is equal to 3. Then in particular for b is equal to a is equal to 3, we have 3 star 3 is equal to 3 minus 3, which is equal to 0. Actually this was 3 plus 3, so 3 plus 3 is equal to 6, which is not equal to 3. Therefore statement 1 is false. Therefore the statement is false. Now the second statement that we have here is, if star is a commutative binary operation on n, if star is a commutative binary operation on n, is a commutative binary operation on n, then a star b star c, then a star b star c is equal to c star b star a so if star is a commutative binary operation on n, then a star b star c is equal to c star b star a. So let's say that, for example, you can define some commutative, which is, of course, the statement is false. Very simple to see that the statement is false, and the reason is that let's define a commutative binary operation star on n as, basically, let's say that a star b is equal to, for example, actually the statement might actually be true, because here we are saying that a star b star c, and here we are saying c star b, and this is commutative. It's hard to find a counter example, but I think it does exist, meaning that if I say that let's see. Okay, so I was actually looking for a good way to, and basically basically when you look at this expression, it seems to be true, and it is actually true, meaning, and there is an interesting way of showing that this is true, meaning that, and I saw that in the solutions. So the solution is that basically if So the RHS of this equation is, the RHS of this equation is R star B star C star A is equal to, well, we said that star is commutative. So that means that if star is commutative, then you can write this expression as A star basically C star B, right? So A star C star B is basically the same as the expression that we have here. Now, since this expression is again since the star is commutative, I can write this as A star B star C. Instead of C star B, I can write B star C, and that is the same thing as the left-hand side of the equation, which means that basically A star B star C, A star B star C is the same thing as C star B is the same thing as C star B star A, and therefore the statement is true. So that was question number 12. So now let's see what we have in question number 13. Question number 13 says that consider binary operation star on n defined as A star B is equal to A cube plus B cube. And you want to choose the correct answer. So let's create some space here. So basically you want to question number 13 is consider a binary operation star on n defined as A star B is the same thing as A cube plus B cube. And now you want to choose the correct answer. Choose the correct answer. Answer A is basically star both associative and well, the answers are actually questions again, so it doesn't make any sense. But let me see what we have here. I don't understand the way that the question has been asked, but the answer, the way that it has been written is a star both associative and commutative. I think what they meant by this is star is both associative and commutative. Otherwise, it doesn't make any sense, right? B is star commutative but not associative. Is star commutative but not associative. Part C of this question is star associative but not commutative. is star associative but not commutative. And part D of this question is star neither commutative or nor associative? Is star neither commutative nor associative? Now the answer here is that since I don't understand the question, I'm just going to simply follow the solution here, see what's going on. And the answer is on n, the operation star is defined as, this is the solution. So you have on n, the set of natural numbers, the operation star. The operation star is defined as a star b is equal to a cube plus b cube, right? Now addition is commutative in n. Well, you can say that since addition is commutative in n, therefore the operation star is commutative. Now it can be observed that one star 2 star 3 is the same thing as 1 cube plus 2 cube star 3, which is the same thing as 1 plus 8 star 3, which is the same thing as 9 star 3, which is the same thing as 9 cube plus 3 cube, which is equal to now 9 cube is equal to 729, and 3 cube is equal to, well, 9 times 3 is equal to 81, or I'm sorry, 9 times 3 is equal to 27. Now 729 plus 27 is equal to 16.1, and this is a 5, 756, right? Now this is 1 star 2 star 3, and 1 star 2 star 3, if I write it this way, so this was 1 star 2 star 3, and 1 star 2 star 3 is equal to 1 star. Basically 2 star 3 would be 2 cube plus 3 cube, which is equal to 1 star. Now 2 cube is equal to 8, 3 cube is equal to 27, 27 plus 8 is equal to 37, 35 is equal to 1 star 35, which is the same thing as 1 cube plus 35 cube, which is equal to 1 plus 35 cube is equal to 42,875. 42,875, which is equal to 42,876. And therefore you can see that, and therefore 1 star 2, 1 star 2 star 3 is not the same thing as 1 star. So over here we had 1 star 2 star 3, and over here we had 1 star 2 star 3, which means that star is not and this is where, of course, 1, 2 and 3 belong to the set of natural numbers. Therefore the operation star is not associative. Therefore the operation star is not associative, right? Hence the operation star is commutative but not associative. So how did we find out that it was commutative? The operation star, okay. So hence the operation star is commutative but not associative, right? Which means that commutative but not associative is this choice here. And of course, as you can see, these are all supposed to be statements, not questions. And so I end these with full stops. And for example, this statement means that star is commutative but not associative. And so if I make that assumption, then choice B is correct. Otherwise, the answer cannot be a question itself. So that doesn't make any sense. I made a mistake here. And so that was question number 13. Now, we have a couple of miscellaneous examples. And then we have a couple of miscellaneous exercises as well. We will go through them, and then we are at the end of this this chapter. So I'll see you in the next video, and thank you.